So in this video we will see the next factor, that is g of s is equal to ts plus 1. So this is the next factor that we are considering. So here g of j omega is equal to 1 plus j omega t. Magnitude of j omega is equal to root of 1 plus omega square into t square, and angle of g of j omega is equal to tan inverse t omega. Okay, this is the magnitude and the angle. So now we will plot it. Omega, real value of g of j omega, then imaginary component of g of j omega, actual magnitude of g of j omega, and angle g of j omega. So I'll take it for when it tends to 0, when it is equal to 1 by t, similar to the previous one what we've done, tends to infinity. So if this is the case, then we will tabulate the results. So first when it is tends to 1, so when it tends to 0, you can see that this term goes to 0. So you remain a square root of 1. Okay, you can see from this one itself. Oh, sorry. If it is real part of g of j omega, then you need to consider only this. No matter what value of omega you take, the real part will always remain 1. You can see you take any value of omega, the real value is independent of omega value. So it will always remain constant at 1. Okay, next we have to look into the imaginary part. The imaginary part is this: when omega tends to 0, the imaginary part tends to 0. When omega tends to 1 by t, the imaginary part tends to 1. And when omega tends to infinity, the imaginary part will also tend to infinity because it is directly proportional. So with that, the real part is 1 root 2 infinity. So this is okay. Coming to the angle, tan inverse 0 is 0 degree. Tan inverse 1 will be 45 degrees, and this is 90 degrees. This is how we have tabulated it. Now we will plot the curve. So this is the curve. Real part of g of j omega, imaginary part of g of j omega. Okay. So with that, yeah. So first one we will start from omega tends to 0. When omega tends to 0, it is 1 comma 0. So that is the so you will have somewhere here. So we can see that your real part is always 1. No matter what, the real part will always remain 1. So when the only the imaginary part is changing. So initially it will be 0. So this is the point. Next, at 1 by t, omega equal to 1 by t, it is equal to 1. So this is the point. And as omega tends to infinity, it is infinity. So here, somewhere here we will plot the infinity. So this is how it will move. Okay, so let me not show the cross one. The cross one depicts the pole location. So I'll just change it to simple points. Okay, so with that, your Nyquist plot is simply a vertical line starting from 1 and moving upwards. So here it is omega tends to 0. Somewhere here it is omega tends to infinity. This one point where the point is 1, this is when omega equal to 1 by. This is the polar plot of Ts plus 1. So the real part is always 1. So the polar plot will be a vertical line. Will be a vertical line. So coming to the angle also, you can see at this point with respect to real part axis, it is 0 degree. At this point it is 45 degrees. Somewhere at the infinity, the angle it makes with the real part will always be 90 degrees. Because if you take some infinity point, such some infinity point on the vertical line, if it will approximately make 90 degrees with the real axis. That is how the 90-degree has come. Fine. So that's it. Next, in the next one, we will start with for different type system, like for type 0 system, for type 1 system, and for type 2 system. How to this is the same procedure. We will reduce the polar plot.